On to graphing sequences. So we have find and graph the first 4 terms of each sequence. Now here's how we usually do this. Usually we think of this as a t-table, where on the left side is our term number, so we want the first 4 terms of our sequence, like that. And on the right side, we plug those into our equation to find what term we need. Now, notice this equation is an explicit formula because I can just plug any n into that. I don't need to know the previous n's to figure it out. So I can plug 1 in to get 8, plug 2 in to get 5, plug 3 in to get 2, and plug 4 in to get -1. Now, as for graphing this, I'm going to graph it kind of like a point, 1, 8. So my first term is up here at 8. My second term is at 5, so second, 1, 2, 3, 4, 5. Third term is at 2. And my fourth term is at -1. Now, here's a very important note about graphing sequences. It's tempting, but do not connect the dots. Sequences are not connected because there is nothing between these 2 numbers. I just have my first term and my second term. I don't have a 1.5 term. That doesn't make sense. So we can't connect these with a line, just leave them as dots. Your first term here, second term there, fourth term there, fifth term down there, sort of thing. So with that in mind, let's try another one. This equation is slightly more complicated, so let's plug stuff in and see what's happening here. Once again, we want our first 4 terms of this sequence. So basically, what I'm going to do is plug that number into this equation. Now, the first one I don't need to do because it tells me what the first one is. The first one is 8. Now, for 2, I'm going to plug 2 in for all my n's. So I have a 2 minus 1, plug 2 in for the n. 1/2, 2 minus 2, plug 2 in for the n. And now I'm going to simplify. So this is 2 minus 1 is 1 times 1/2 to the 0. Now this is the answer for a sub 1. I know that a sub 1 is 8, so I can plug that in. And 1/2 to the 0 is 1, so that's going to be 8. So now let's plug 3 into that equation. So I plug 3 in for n. So here I need that becomes a sub 2 and 1/2, oops, that should be a 2, to the first. And I just found out what a sub 2 is from the line above. A sub 2 is 8 times 1/2 gives me 4. And let's do the last one, plug 4 into my equation. So this becomes a sub 3 times 1/2 squared. Now I just found a sub 3, that one was 4. And 1/2 squared is 1/4. So 4 times 1/4 is 1. Now, you probably noticed as we were going through this that this is an example of a recursive formula, meaning that to find a sub 4, I had to use the previous term, a sub 3. If I didn't know what a sub 3 was, I wouldn't have been able to calculate this. So this recursive formula, you have to know the previous term to find, the next term. Now we can graph it. First term was 8. Second term was also 8. Our third term was 4. And our fourth term was 1. And there we go. So now that we're doing pretty good, let's keep going. We've got a much weirder looking sequence this time. However, it's still the same idea, where we're going to plug in 1, 2, 3, 4 in for n in here. Now, I would like you to try this one. So plug 1 in for n, simplify it, plug 2 in for n, simplify it, 3 in for n, and so on and so forth, and then graph them all. So pause the video, try to figure this one out, and then come back to check and see how you did. Let's see how you did. So all I did was I took whatever my n number was and I plugged that in place of those 3 n's. So n, 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 and then simplified it. And here I put n, 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 simplified it. And so on and so forth. And when I simplified it, these are the answers I got, which I then graphed. However, I did want you to notice that this part of the equation right there, that is just there to determine the sign. This is one of the ways that we write alternating signs into an explicit formula for a sequence. Because this one makes it positive, this one makes it negative, this one makes it positive, this one makes it negative. So this part of the equation right there is there to alternate the signs. And this one starts with a positive sign. If you want it to start with a negative sign, you would just do -1 to the n, leave off that +1. And then it would start negative, positive, negative, positive. So that is what that part of the equation is for, which is going to be helpful in the future of this lesson when we need to come up with equations on our own that fit these sequences. Last graphing example. Same deal. Pause the video, try to graph this out on your own, and then come back to check your work and see how you did. Let's check your work. I plugged in all my numbers for n. Here's the answers that I got and that I graphed. Now, you may have noticed that 2 of these graphing sequences we did look a lot like graphs you've seen before. Mainly, this one looks like a linear straight line, and this one looks like an exponential curve. That is actually on purpose. Those 2 sequences have special names. So this one, when it's a straight line, it happens when we're adding or subtracting the same number over and over again to get the next number. When it looks like an exponential graph, that means we're multiplying by the same number over and over to get the next number. So you'll notice here we're multiplying by 1/3 to get to the next number. And that gives you that exponential curve. That is what we'll talk more about in the next video. Those do have special names that we're going to dive into more deeply.